This tutorial video will demonstrate how to use the mole concept to convert from moles of a substance to grams of a substance, as well as from grams to moles. So starting with 3.20 moles of silicon, I need a conversion factor. Moles is on the bottom because I already have that, and I need grams of silicon. I can look in the periodic chart and find the atomic mass of silicon is 28.1. And this allows me then to convert. I multiply through, and I find that I have 89.9 grams of silicon in 3.20 moles of it. For oxygen, it's the same thing. 1 mole of O2 will have a mass of 32 grams of O2. And so this cancels out my units perfectly, and it allows me to multiply through and determine that I will have 102 grams of oxygen. To go from grams to moles, it's the same idea that we're going to use a conversion factor, except this time the moles go on top and the grams will be on the bottom to cancel everything out nicely. And so when I multiply through here and perform my calculations, I'm going to have 1.96 moles of silicon. For oxygen, it's the same thing as before. Moles on top, grams on bottom, because that's what we want to change from. 32 grams in 1 mole, and with 55 grams of it, I'm going to have 1.72 moles of oxygen. So one last thing we can do with the mole concept is actually use the quantity of moles that we have here to determine how many atoms of silicon and how many molecules of oxygen we have. And that's because 1 mole of anything contains 6.02 times 10 to the 23rd copies of it. Just as a dozen of something will contain 12 of those items, or a pair of something will contain 2 of those items. So Avogadro's number times the number of moles for our silicon will give us 11.8 times 10 to the 23rd silicon atoms. If I want to write this using proper scientific notation, that's 1.18 times 10 to the 24th atoms of silicon. I can do the same thing for the 1.72 moles of oxygen from the previous problem, recognizing that while Avogadro's number remains the same, 6.02 times 10 to the 23rd, this time I have to be talking about molecules of O2 versus 1 mole of O2. And so in this case, when we multiply through, we get 10.4 times 10 to the 23rd molecules of O2, which is 1.04 times 10 to the 24th molecules of O2. The number of atoms in this 1.72 moles of oxygen gas would be twice the number of molecules, because each molecule has 2 atoms of oxygen. And so this is an example of how you would use the mole concept to convert between moles and grams, as well as count up the number of atoms or molecules in your substance.